Greetings. In this video, we will be looking at an introduction to database management. At the end of this video, you should be able to accurately explain the concept of a database, clearly state the purpose of a database, correctly use terminologies associated with a database, and create or draw a table structure. If you're new to this channel, you should subscribe so you do not miss any new videos. Also, if this video was beneficial, please like and share. Thanks. So, without further delay, let us begin. What is a database? Well, a database is an organized collection of related data, right? Databases are sometimes called a repository of information. Modern databases can store millions of records and allows retrieval of requested data within a mere second. Right? Just remember that. Data can be stored in manual databases and computerized databases. Examples of manual databases are phone book, catalogs, and filing cabinet. Computerized databases were developed to make the storage and retrieval of information faster and easier compared to manual databases. Computerized databases are sometimes called DBMS, which is Database Management System, right? And DBMS stores data in a structured and organized way. This contributes to faster retrieval time compared to manual databases. DBMS requires less physical space. For examples of DBMS are Microsoft Access, Oracle, MS SQL, and MySQL. Right? Cool. Here are some advantages and disadvantages of manual databases, which you should know. Right? Here are some advantages and disadvantages of computerized databases, which you should know. So what you can do is pause the video and go through them, and then you press play. Alright, so in order for you to be proficient in database management, there are some terms that you should readily know, right? So when somebody comes to you and say, what is a record? Off the top of your head, you should just know, right? So the first term that you should know is what we call a relational database. And a relational database is a database that contains more than one table. Remember that. Tables in a relational database can share data amongst them via what is called a relationship. Cool. Alright, the next term is relationship, and relationship is the linking of tables and files to share record or data, right? And the next term that you should know is what we call an attribute, and an attribute is the individual properties of an entity, and this is called an attribute. An attribute is represented by a field in a database, right? So an entity would be like the thing you're storing information on, like a student. So a student would be an entity, and an attribute of that entity would be first name, age, surname, height, etc. Right? Cool. The next term that you should know is a field or a column, right? And a field is a single column in a table that stores data. Remember that. A field is a single column in a table that stores data. And as I have said before, a field is sometimes referred to as an attribute. So in the database world, you might see persons referring to a column as a field, or you might see persons referring to a column as an attribute. So those names are interchangeable, right? Cool. The next term that you should know is what is called a row, and a row is a collection of all the columns in a table that is associated with a single occurrence, right? Just remember that. Alright, the next term that you should know is a record, and a record is a collection of related fields, right? It contains a single row and many columns. In relational databases, records are also known as tuple, right? Just remember that. So, which leads us to our next term, which is a tuple. And the definition for a tuple is that a tuple is represented by a record in a database. So, in the database world, you might see persons interchanging the word tuple, record, or row, right? Cool, let's move on. Now the next term that you should be aware of is a table, and a table is a collection of records made up of set of rows and columns. The information you enter into the database will be stored in a table, right? In a relational database, tables are sometimes called relations. Remember that. A table has a specified number of columns but can have many rows based on the number of records you are saving, right? Just remember that. Alright, just remember that a record, tuple, and row are considered to be the same thing in a database, while field, attribute, and column are considered to be the same thing in a database. Here I have a sample table. This table has 2 columns. See, 1, 2, fields or attribute, and 3 records, tuple, or rows. Okay, you remember that a record can be called a tuple or a row, and a field can be called an attribute or a column. So here's a sample table. It has 2 columns, which is this one, column 1 and column 2, and it has 3 rows or records or tuple, which is row 1, row 2, and row 3, right? So let me show you. So we have 1 column here, 1 column there, 1 row going across here, another row here, and another row here. So that's 3 rows and 2 columns. Do you realize that I did not count this row in the number of rows, because this is the header, right? So you do not count it in the number of rows that the table contains. Just remember that. Alright, let's move on. It is super important that you become comfortable with these terms. Make it your ninja way to learn them well. Alright, let's continue to look at terms associated with databases that you should be comfortable with, right? And the first term is report. Reports in databases are used to represent information retrieved from tables, right? And present it in a manner that is appealing to the user in a summarized way. Reports can be created from queries or from tables. Remember that. The next term is forms. Forms allows database users to type data into a database using special design templates rather than straight into the table. So forms are designed then for data entry, so you do not need to enter the data directly into the table, right? The next term that you should know is a file. And a file in terms of a database is a group of records that make up a database. So the whole database is a file, right? And within that database you would have tables, queries, reports, etc. Cool. The next term that you should know is what is called a field description. And a field description describes what is in a field, right? So it's like a comment of what is inside a field, what is stored inside a field, right? This description is displayed in the status bar in most databases, especially Microsoft Access, which we will be using for these video lessons, right? When you select the field on a form, the field description is shown. Cool. The next term that you should know is field size. And field size determines the amount of information or character that can be stored in a field, right? Remember that. The next term that you should know, and this one is very important, is what is called a primary key. And a primary key is a field that acts as a unique identifier for each record in a row, right? So in essence, a primary key can be used to uniquely identify a record in a row. Most of the time when you create tables, you want to make sure that your table has a primary key, right? Because this is what would be used to uniquely identify each record. And the primary key assists in data retrieval, so data is able to be retrieved quickly from the database. Remember that. Alright, the next term that you should be aware of is what is called a candidate key, right? A candidate key is a field that could possibly act as a primary key in a table. So for instance, if you have two fields in a table that could be used to uniquely identify a record, those two fields would be what we call a candidate key. But out of those two fields, you would choose one that you would use to uniquely identify records in a table, and that key that you choose would now become the primary key. So just remember that. Alright, the next term that you should know is what is called an alternate key. And an alternate key is any candidate key that is not the primary key, right? Alternate keys are sometimes referred to as secondary key, and as I've explained just now, if you have two fields in a table, right, both of them could be used to uniquely identify records in the table, but you choose one, right, which would be the primary key. The other one that you did not choose is what is called a secondary key or an alternate key, right? It's a candidate to become a primary key if you want it to be, right? All right, the next term that you need to know is what is called a composite key, right? And composite key is a primary key that consists of two or more fields together. So most of the time when persons create primary key for tables, they use one field for the primary key. However, sometimes when you're creating table, rarely, but it can happen, you do not have one field that can be used to uniquely identify the records in a table. So what you can do is use a group of fields, and that group of fields is called a composite field, right? And you would use those group of fields to uniquely identify the records in the table, and that would be composite key, right? Cool. The next term that we're going to look at is what is called a foreign key, and this one is an interesting one. Foreign key is a field in a table that has been linked with the primary key field of another table. So for instance, if you have two tables in a database, and you link both of them together in one of the table, the keys that you use to link both of them together, in one of the table it would be the primary key, and in the other table it would be the foreign key. But as we go along and do practice questions in Microsoft Access, create tables, etc., you will appreciate primary key and foreign key better, right? The next term that you should know is a query, right? And a query is a database feature that allows you to display records that meets a particular criteria, or to display records from a table. So most of the time persons use query to extract a certain amount of data from a table that meets a particular criteria. So let's say for instance you have a table in your database, and the table contains the name of all the students in a school. Let's say it's 50,000 students in that school, but you only want the students that are in grade 7, right, to be shown or to be given to somebody. What you could do now is write what we call a query and extract all the students from grade 7 from that big table that would contain all the students in the school. So just remember, so a query is a database feature that allows you to display records that meet a particular criteria. All right, let's move on. The next term that you should know is what is called a calculated field, right? And calculated fields are a special type of field. The value of the field is not stored within the database record, just remember that, but is instead calculated or computed based on the value of other fields within that record, right? The calculation is called a formula, and this formula can consist of values from other fields, constants, and the results of a function. So in essence, calculated fields are created, alright, and when you run your queries, the result is calculated and returned. So you don't enter data for the calculated field, rather you type the formula to calculate the values in that field, and when you run your queries or your tables, it fetches that data and returns it to you based on the calculation. Alright, the final term that we need to look at here is what is called a table structure, right? And this is critical for when you're creating your database tables, right? So table structure is a plan that shows the names, data types, and the field size of fields in a table. So let me repeat that. Table structure is a plan that shows the names, the data types, and the field size of the fields in a table. So normally when you're going to create a table, you could create a table structure, and then from that table structure you'd go to your application such as Microsoft Access and design your table using that table structure, right? I will be showing you how to create a table structure in this video, so don't worry about it. Alright, let's move on. Now the next term that you need to know is what is called a data type, and this is critical when you're creating your tables and your table structures. So what exactly are data types? Well, data types are field types. They determine the type of data that a field can store, right? When a database is designed, all the fields are set to accept a particular data type, right? This helps to check for the wrong type of data being entered and make sure that data is stored as efficiently as possible, right? It also means it will be stored correctly, right? So that is what a data type or field type is about. Now there are four main types of data types. They are alphanumeric, right, or text. You have numeric fields, you have logical or boolean fields or data type, and you have the date field type or data type, right? And an alphanumeric or text field will accept both numbers and text values. Remember that. Now when to use alphanumeric data type? If you want to enter text or mixture of text and numbers, then the alphanumeric data type is perfect. Alright, so when not to use an alphanumeric or text field? Well, if you want to store only numbers or only dates, then this is not a good data type to use. You would probably want to use the numeric data types or the date data types, right? Numeric fields are numeric data types. When would you use a numeric data type? Well, you would use a numeric data type or numeric field when you want to store numeric numbers such as decimal, integers, etc., right? Then you have the logical or boolean field, right? And logical or boolean field will let you enter one of two possible values. Most of the time it is yes or no, or you have a checkbox where you can place a sticky in or no sticky, right? When do you use a logical boolean field? Well, when you only need to store something that is either true or false, or if you want to store something that exists or doesn't exist, right? Just remember that. Alright, so the last field type that you need to know about is the date field type, right? A field of this data type stores date, right, in terms of days, months, and years. Date field can display the date information in different formats, right? So for instance, in some format you can have the day first, then the month, right, and then you can have the year, argument's sake, 2020. Now this can be written or be typed in different format based on what you choose when you're creating your table. Just remember that, right? When to use? Well, you would use a date field for any field which would store date information. Just remember that. Alright, let's move on. So here are some sample data types that would fall under the four main data types that were used in Microsoft Access, right, which we will be using for this video lesson, right? So for the alphanumeric data type in Microsoft Access, it would be called text or memo, right? Just remember that. For the numeric data type in Microsoft Access, you have currency, number, and auto number. And auto number is a special data type which we will look at in future videos. Then in Microsoft Access, for the date data type, you have the date/time. And in Microsoft Access, for the logical or boolean data type, you have the yes/no data type. And we will look at these data types in action when we go into Microsoft Access and design some tables in future lessons, right? Alright, cool. Now finally, I'm going to show you how to create a table structure, right? And if you remember, a table structure is a plan that shows the names, data types, and the field size of a table, right? Table structures are normally created before an actual table in a database is created, and I've said this before, right? So I'm going to use an example and I'm going to create the table structure for it so you can better appreciate this concept. So for this example, I will walk you through the steps of creating the table structure for a table called stock. Now let's say you want to create a database called hardware. So hardware will be the name of the database, not the name of the table, the name of the database. And in future videos I will show you how to name your database, right, with one table called stock. So the name of the table that we want to create is called stock, and this stock table will be stored in a database called hardware, right? Now the stock table, right, should have 4 fields. So right off the bat we know that there should be 4 fields right in this stock table, 4 columns, right, which are book title, author, ISBN, and number in stock. So it means that the table that we're going to create eventually will have these 4 fields in it: book title, author, ISBN, and number in stock. Cool. So let's see how we would create the table structure for this table called stock. Alright, so the first thing that you would want to do is draw a table with 4 columns, right? 1, 2, 3, 4. The number of rows in the table that you draw is dependent on the number of fields that will be in your table, or the number of fields that was given in the question, right? So for instance, for our question that we're gonna be working on, we were given the fields book title, author, ISBN, and number in stock. So these are the 4 fields that we were told would be a part of the stock table, right? So once you draw a table with 4 columns, 1, 2, 3, 4, you will then name each column in the table that you draw, right? The first name you will call field name, then you will call the second column data type, then you will call the third column field size, and then the last column you will call description. Now please note that even though I'm using 4 columns, you can actually expand this table by using 5 or 6 or 7 columns. However, for general purpose or general use, mostly 4 columns are used, right? Good. Now that you have this table and you label it with the headings, the field name, data type, field size, and description, what you want to do next is put the fields that will be in your table under the field name. So what I'm going to do, I'm going to put book title in the first row, and I'm going to put author in the second one. I'm going to put ISBN in the third one, and then the last one I'm going to put number in stock. Now one more thing that I want to show you, not because you are giving the field name as book title or author or ISBN or number in stock, you have to name them exactly, right? You don't have to. You could call book title B title, or you could call number in stock, for instance, number. You could call this one number stock, right? Just to give you an idea that you have options in terms of how you name fields in a table. However, we're gonna stick with the original name, number in stock, since that is what was given. Alright, so once we have entered the field name, the next thing is to put data types for the field name. So book title, right? Book title would more or likely be words, alphanumeric characters. Example for book title would be like Macbeth or Green Days by the River or Miguel Street, right? And you know that book titles can be long sometimes taking up like 100 characters or 120 characters, right? Now a very good data type for book type is alphanumeric, right? It's text. If you remember that there are different types of data type, let me go back. If you remember that we have 4 main type of data types, we have alphanumeric, we have numeric, we have date, and we have logical. And under alphanumeric we have text and we have memo, etc., right? So in this column we're going to choose one of the data types that we know, right? So book title, we can say, okay, the type of data that will be stored in book title field is text, not true. And then now based on the titles that you're going to enter into your table, you have to now decide what is the size, what is the largest title that will be entered into this field, right? So I don't think the title of a book will pass 230 characters. I don't think a book title will be that long. So what you'd have to do is determine the longest characters or the longest value that will be entered into this field. So for a book title, I have never seen a book title that is more than 200 characters in length. So I'm going to say the largest value that might be entered into the book title column or field will have 200 characters. So I'm going to enter 200 here. And for the description column now, what you're going to basically write or type is what will be stored in the book title, or you're going to just write a brief description of the book title field. So I can write something like this field will store title of books for the stock table. You know, it's basically a description of what the field is all about. All right, so for the author field, we're going to do the same thing. And you know that for author, you basically store the name of the author. So in this case, I will be storing the first and the last name in the author column, right? It means then that I will have to make a decision of how long the largest value will be that will be entered into the author field. Alright, so I don't think a name will pass 60 characters. So I'm going to say, okay, the type of data that will be entered into the author field or the author column is text, or you can say alphanumeric if you want, and the size of the largest value that will be entered into this field might be like 70. Right? And for the description, I'm going to put a brief description of what the author field is all about. So alright, and I'm going to do the same thing for the ISBN and the number in stock. Alright, so for the ISBN field name or field, I change the data type from text to alphanumeric just to show you that you have options in terms of what data type name you use, right? And for the number in stock, I'm going to use numeric because based on what the description says, it stores the number of books in stock, and this would be a perfect field to use numeric data type. And for the field size, I'm going to use integer. For the field size for numeric data type, there are a number of predefined field size names that you can use. However, the two most used ones are integer or decimal, right? So you choose one of those, integer or decimal, but as you go along you will learn more and you can use them. So right off the bat, what we have just done is create the table structure for a table called stock. So table structure for stock table. So this is an example of the table structure, right? Cool. Now this is how the table structure would look. An example of how the actual table will look, right? So we would use this table structure to create a table looking like this, right? Which we will look at in future videos. So let us look at one more example, right? So here's an example. It says that you're supposed to create a table structure for a student table which will store a student name, age, gender, and date of birth. No student will have a name with more than 60 characters. Alright, so right off the bat, the question gives us 1, 2, 3, 4 field name, right? It gives us, so we are going to need more rows. So let me insert some more rows, right? Good. So it gives us date of birth, which I'm going to call DOB, just to show you that you have option in terms of how you name your field, right? But most of the time we try to name our fields as short as possible with names that are meaningful as possible. So I could call the date of birth field D, or I could call it O, Alright, could call it DO, but those names are not that meaningful. Not true. You can't just look on it and have an idea of what data is stored in that field. So if you call it DOB, then that is self-explanatory. Not true. Right off the bat, you know that the data that will be stored in this field are probably date of birth. Right. Alright. We have gender. Right. And just to show you that you have options, because the question does not specifically state that you must name the field gender, you could call it sex, right? Because you know that sex is male or female, etc. But I'm gonna stick with gender just to show you. Or you could call it gen, right? You have options. So gender, age. Alright, now for the student name, you have option, right? You can store the student. Let's say you're gonna store the student full name, John Brown, the first name and the last name. You can either store the student name in one field, or you can split the student name in more than one field. And this is what I'm talking about. You could create a field called name, and in that field name you would have the student full name, for instance John Brown or Mary Jane. Or you could split the name field into two fields, first name and last name. So the name field, the student name field, you could actually split it into two fields. So we could call one first name, and you realize that I joined both words together. You can do that, right? Or I could separate them, right, like that. Or I could use an underscore character to join both of them, first name, right, and another name called surname or last name, whichever. But the key thing that you should take away from this is that fields that stores composite data, you can actually split them up. And a good example is the name field here, where I could store the name of the student in one field. However, I decide to split it up into first name and surname, right? Cool. Alright, so for the first name, the data type for the first name, right, is text, because you know that person's names are text, alphanumeric characters, not true? And the field size, I'm going to put it at 70. Why 70? I'm just saying that, okay, I don't think anybody have a first name that I'm going to be entering into my table with a character or a value larger than 70 characters, right? So that is why I put 70. But if you're creating a table structure and you decide that, okay, I don't think anybody is going to have a name with characters greater than 30, then for field size, by all means, put 30. That's what I'm saying. However, try to give yourself room, so just in case you buck up on somebody with a larger name, then you know that your table will be able to accommodate that name, right? And for the description, I'm going to say, okay, this field stores the student first name. So I'm going to quickly do the rest and then explain it. So for surname, the data type is text or alphanumeric. I don't think any person has a surname larger than 100 characters. Okay. For the description, I'm going to say, okay, stores student last name. For age, more likely the age is going to be a numeric character. So I'm going to put numeric. Right. Field size, the age is going to be integer, because you know you can't be like 10.5 or 6.8. You're just 10 or 9 or 6, which is a whole number. So I'm going to put integer, right? And stores student age as whole numbers, right? Gender, now gender is going to be a text because you're either male or female. Now let me show you something interesting. You're either a male or female. So look here, you have male, which female, and you have male. Now for this field gender, the largest possible value that will be entered is this female, and it has 1, 2, 3, 4, 5, 6 characters. So it means that for the field size, I could put 7 or 8, just give myself some room, right? Alright, for the date of birth, the data type would be date, and we leave this blank. And I'm not going to put any description here, just to show you that you can actually leave the description fields blank. And what we have basically just done is create a table structure for this question. So when you're creating table structures for tables, the key thing that you need to know, you need to be aware of your different data types, right? Which are these things here. You have the alphanumeric, you have the numeric, you have the date, and you have the logical. And you need to be aware of the fact that when you're naming your field, you have flexibility, right? Not because they give you a field called gender, you have to use the word gender. You could use the word sex, or you could use the word gen, or you could use the word gender. You understand, you have flexibility, but what you want to do is try to name your fields that would self-identify what data is being stored in the field. So that's the key thing, right? All right. Okay, so that's the end of this video. In future video, I will show you how to create tables using Microsoft Access, and I will show you how to create forms and reports and create calculated fields and how to do the table structure in Microsoft Access. But for now, what you need to do is know the different terminologies that are associated with a database and know how to do a table structure for a given table. All right, bye.